Okay, in this video we're going to look at multiplying complex numbers. And let's just consider a couple of examples and see that multiplying complex numbers is pretty straightforward. For example, 2 plus 3i times 5 minus 2i. Well, as you might kind of guess, we're going to distribute just like you would in a normal multiplication problem. Right, we would go through 2 times 5 is 10. 2 and 2i would be a minus 4i. 3 and 5 would be plus 15i. And then 3 and 2 would be minus 6i squared. Very much like you would multiply two polynomials. It's really the same exact idea. Now you would have some like terms that can combine. Specifically, we have a negative 4i and a 15i. Would become 11i. Now here's where the complex numbers and their arithmetic gets a little bit different. See, because I squared, if you go back through our powers of I, is equal to negative 1. So we can use that right here to replace the I squared in that minus 6i with a negative 1. And that allows us to simplify further with these complex numbers than we would be able to do if it was just a regular old polynomial. And so that's going to make that a plus 6. And so then we have 10 plus 6 makes that 16 plus 11i. And so when you have that I squared, it's going to become a negative 1. That allows us to go just a little bit further than what you would normally be able to do if you were just multiplying polynomials. Okay, let's consider another example. So we have 3 minus 5i times 4 plus 7i. Well, again, we can distribute through. 3 and 4 would be 12. 3 and 7 would be 28i. Negative 5 and 4 would be minus 20i. And then a negative 5 and a negative 7 would make that minus 35i squared. And then we combine our like terms. The I squared, again, is going to become a negative 1. That's going to become a negative 1, so that's going to be a minus 35 times a negative 1 is going to be plus 35. So we'll have 12 plus 35 is 47. And then 28 minus 20 is plus 8i. Okay, so that is how we multiply complex numbers. We're going to finish with one last example that kind of shows us something kind of neat. So consider 4 minus 9i times 4 plus 9i. Now you could distribute that out or recognize that the 4 minus 9i and the 4 plus 9i are taking on the forms of a difference of squares. So that would just be 4 squared is 16 minus 9i squared, or 81i squared. But I squared is equal to a negative 1. So that's going to be 16 plus 81 is equal to 97. And it turns out anytime you have a pair of complex numbers that are taking on the form of a difference of squares like this, when you multiply them, you're going to get a real number. In fact, we have a definition for these. A plus bi and a minus bi are complex conjugates. And anytime you multiply a pair of complex conjugates, the result's going to be a real number. And this is actually going to be important when we get into dividing complex numbers in the next video. Till then.